Hello friends, I am coming with question number 10 of Pathfinder Newton laws of motion. What is the wording of this question? The question is saying that in the setup shown the string is inextensible and light. There is no friction at the axle of the pulley, but friction between the string and the pulley wheels is sufficient to prevent slipping. All the pulleys are light except the pulley P, which has whole of its mass small m concentrated in its axle. Initially, the block B of mass capital M is on the ground, and the block BA is held at rest. How much minimum mass should the block A have so that after releasing it the block B starts rising? Some options are given. I tell you one thing, some important information is given. It is given the string is light and inextensible. There is no friction at the axle of the pulleys, but friction between the string and the pulley wheels is sufficient to prevent slipping. That is mean the all pulleys are rotating because of the friction is present. So what is the meaning? Just look at please carefully. Let's assume this is your pulley, and in this pulley the one string is wrapped. Let's say this string is passing from this pulley. So these are the ends of the string. We know very well the tension is developed at the touches point. So here the tension T, and of course this is a light string, so here it is also tension T. But because of rotation, let's assume this is rotating in counterclockwise. Okay, if it is rotating, then this surface, this side of the surface, if I'm talking about this part, so in this case I tell you one thing, what is happening, the friction force is present. So once the sliding wheel occurs, immediately friction force will involve, and this friction force is acting in this direction. And in this side, if you're talking about this side, so in this side the friction force will act on the string in this side. So you can say that the other side of the portion friction force on the string is acting in the direction of tension, and another side the friction force is acting in the opposite direction of tension. Because of this reason, my dear friend, because of this reason, the net force on the strings at the edges is different. So if this is rotation, so in the condition of rotation, I tell you one thing, the tension at both ends, here it is tension T1, so at this end the tension is T2. Understood? This is the case. So be remember what, in the condition of rotation of pulley, tension on the string at both ends are different. If tensions on the string at both ends are different, then we can go with very easy case. Now entire question will finish, simple question. So before, let's see, this is your diagram, and in this diagram what is happening, so some informations is given. So there is a pulleys, all pulleys are massless except the pulley P, and my dear friends, the mass is M. So if I'm talking about the capital M mass, this mass B. So if this mass is B, so first of all normal should be acting in this direction, tension should be acting in this direction, and G in this direction. So if this block start rising up, if block B starts rising, the normal becomes 0. Understood? This is the first line. Normal becomes 0. So means T is equal to mg. This is the case, simple case. T is equal to mg. Now look at this pulley. So of course this pulley is rotating, as I tell you. So if this pulley is rotating, then the both ends of the pulley experience a different tension. Let's say here it is T1, here it is T2. This end is T2, so this side is tension is T3. Of course, this pulley is also rotating, so this side tension is T4. This side tension T4. This pulley is also rotating, so this side tension is T5. And why this is rotating? Because the friction is involved. Understood? So T5, here it is also T5. And this side the tension of course T1. So here it is the tension T1, but this side the tension is T6. Here it is also T6, and here it is MAG, and pulley P has a mass capital is small m. So because of this reason, small mg is acting downward. So now I tell you one thing. If now one most important information is given in this question, all the pulleys are light except the pulley P. So let's assume if pulley Q has no mass, if pulley Q has no mass, that is the moment of inertia of the pulley is 0. So net torque on the pulley is also 0. This is the most important information. Net torque is 0, that is means T1 into R minus T2 into R is equal to 0. We can say that the T1 is equal to T2. My dear friend, I tell you one thing, little mistakes I am doing. This is also T2. So this terminology is T2. So because strings is ideal, so here it is T2, so here it is also T2. So you can say that now similarly for other pulleys also, except pulley P, for other pulleys except pulley P, we can say that if I am talking about this R pulley, so T4 and T2s are same, so T2 is equal to T4. And S pulley, if I am talking about S pulley, so and T4 is equal to T5. And similarly, look at the case, very easy. So we can say that the T1 is equal to T2 is equal to T4 equal to T5. My dear friend, listen. If T1 and T5 are equal, then look at this pulley P. There is a pulley P, and in this pulley P, one force is acting upward and other force is acting downward. So if this side is force also T, and here this side is some forces acting, so this side force is T and this side is also force T. So overall, because of this reason, the net force, if this and this are same, then this side tension becomes 0. So we can say that, the mass A, the rising condition of B does not depends on mass A. Does not depends on mass A. This is a very beautiful concept. Okay. So first means what is 0.5 m? Wrong. 0.5 wrong. Whatever the mass of the block A has, the block will not rise. You can say that C. Understood? Now I'm starting to talking about the D option also. Look at here. If T and T is 0, so this is going downward with mg force also. So our net force is acting mg downward. Because of this reason, the pulley is moving downward. Pulley moves downward without rotation. So this is a simple question, and you can learn the concept of rotation of pulley also. Thank you so much for seeing these videos, and please subscribe my channel.